Am I audible, students?
Yes, ma'am.
Yes, ma'am.
So, which experiment we have completed yet on the last session?
MCB, LCB.
Six.
Today will be the assessment, right? So today is the assessment for experiment number 6, students, and
Ma'am, that's a request. Ma'am, can you take our assessment in the next lecture as from today our sessionals are going to start?
Yes, ma'am.
Yes, ma'am.
Please consider the
Yes, ma'am.
request.
Yes, ma'am.
so how many of you want to give today? Please raise your hands. Anybody wants to give today? So how many of you wants to give on next session? Okay, so most of the students, I mean almost all the students want to give next session, right? So I am considering your request for means I will take the assessment on next session. I am considering your request due to the sessional exam only, right?
Thanks a lot.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
But after the sessionals, we will follow the same pattern, right?
Yes,
There will
sure,
be
ma'am.
no change.
Yes, ma'am.
So till now, we have completed experiment number 5 assessment. Means 1 to 5 assessment of experiment 1 to 5 we have completed. Right, so 6th is remaining. And whatever we will complete today, okay, if suppose if we complete experiment number 7, so both will be taken on the next session. Can you hear me, students?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, so we are now starting experiment number 7.
Okay.
Okay, can you see manual, students?
Yes, ma'am. Yes, ma'am.
It's visible?
Yes, ma'am.
Okay, fine. So this is the experiment number 7 of this lab. So the aim of this experiment is demonstration of various home appliances, right? So in this experiment, you will learn about the working of various home appliances like the fluorescent tube light kit, the fan with regulator, the iron, the heating coil, the growler, right? So these home appliances we have in our daily life. We use them regularly. Okay, so there is no need to explain you what is the role of tube light, what is the role of fan with regulator, iron, heating coil. I think you know already these things, right? So we'll discuss the working construction, how they work, right? We know what work they can do, but what how they will work, we will discuss these things. Okay. So we'll learn about fluorescent tube light kit, fan with regulator, crawler, iron, heating coil, right? So tube light, we daily use uh, the tube light for illumination. fan we daily use, we have ceiling fans in our home. Okay, then we have the heat electric iron to iron our clothes. Okay, then this is heating coil, means we will learn about here the induction cooktop, right, that we use for the cooking. Nowadays it's very popular, modern style of cooking, modern equipment it is. So, and growler we'll see why we use growler. Is not an popular home appliance, it is a testing equipment, right? So we will study this also. Now if we are talking about the fluorescent tube light kit, okay, so you already know this is the tube light, okay. Actually this is the lamp filled with the argon gas, right, filled with the argon gas, okay, and these are the holders, okay, holders of the lamp. So inside this lamp there are filaments or electrodes you can call, okay. So if you are providing the voltage or current, means current flowing through the circuit, switch on, if you are switching on the supply, so that electrodes will generate electrons and inside electrons to this lamp, and the argon will be ionized, and the argon has the property to illuminate, right? So it will illuminate. But in the starting, the tube light needs a very high voltage to get ionize the argon gas, right? So what we are doing, we are switching on the supply through the switch. So in our home we get 230 volt, but in tube light we want, in starting tube light needs more than 230 volt. High voltage it requires to get started initially, right? उसके बाद में it's okay, it will running, right? It will illuminate. So the thing is how to provide this high voltage initially to on this tube light, right? So for that purpose, we need to connect one ballast. Ballast means the choke coil and a starter. Understood, students? Can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So give me 5 minutes, students. I will change my place because there is lot of crowd and noise. So I will change my place. Give me 5 minutes. Don't leave the meeting. Okay, students, am I audible to you?
Yes, ma'am.
Ma'am.
So basically, to provide the initial high voltage, we have this choke coil and starter with this tube light kit, right? So this is actually ballast, which is a choke coil, nothing else, right? And the connection will be like this. So I will share one actual circuit diagram in which you will see how to connect this tube light. So this is the diagram, student. You can see here, this is the switchboard. Okay. So here we get have already 230-volt single phase AC supply in our home. Okay. Now from this switchboard, you can see this red wire is a phase wire, and this black one is the neutral. Okay. So this phase wire is going to the choke coil. That is nothing but the inductor with some resistance. Okay. Then it is connected in to this. This is called the filament electrodes, right? And inside this there will be in this lamp. This whole part is called lamp. So inside this there will be the argon gas, right? And we'll connect this choke coil in series with this switch and this tube light, right? Then the other terminal of this electrode is connected to this starter. This is starter. The second terminal of starter is connected to this terminal of the tube light, and here is the neutral, right? Right now you can consider the starter connected in parallel. This is connected like a parallel connection. What is inside the starter is one. It is filled with the neon gas, right, or argon gas, right? This starter also filled with this gas. Then there is a bimetallic strip. Okay, and it's a capacitor. So what will happen here? At initial stage, at the starting, the capacitor contacts, these are bimetallic contacts, right? This one and this one. So they are not closed, they are open. It's open right now. So current cannot flow and the circuit cannot be completed, right? So what happened here? But we are giving the supply from here. So all the voltage, when you are switching on the supply, all the voltage will appear across this starter only, right? because there is no current, so this will be means parallel with this, right? Understood, students? Understood or not, students?
Ma'am,
Yes,
can
ma'am.
you explain again starter?
The contacts of these starters are not close. This contact, this one and this one. You can see here, this is not closed, no? It is open.
Yes, ma'am.
So path of the current cannot be completed. Means
Yes.
current cannot complete its path. So what will happen? No current is flowing in the circuit, right?
Yes, ma'am.
And all the supplied voltage is what? 230 volts. So all the voltage will appear across this starter because it is in parallel right now.
Yes.
It is parallel with the supply, no? This red phase wire and neutral wire, and this is connected here.
Yes, ma'am.
Okay. So due to this 230 volt, what will happen? This inside the capacitor, inside this starter also we have this argon or neon gas. So that will be ionized, right? And the temperature will increase. Okay, temperature will increase. Okay, so if temperature will increase, there is a bimetallic strip which will bend. It will bend and it will close the contacts, bimetallic contacts. Understood?
Yes, ma'am. Yes, ma'am.
And one flash will also occur here due to this gas, right? Now it is closed, so now this starter will be in the series. Okay, so current is flowing, and this choke coil will EMF will appear across this choke coil, right? E equals to minus N. Okay, understood?
Yes, ma'am.
So this E is the voltage across this choke coil, and this is the supplied voltage, and these both are in series, the choke coil connected in series. So what will be the total voltage across this lamp? It will be 230 plus E, right?
Yes, ma'am.
So that is the voltage which the lamp needs to be illuminated. Means this voltage will appear here, 230 plus E, right? So what will happen inside there is argon gas. So this current is passing through this electrode to this gas, and this has the property, and it will illuminate, right? It has an illumination property, right? So it will illuminate. Likewise in capacitor in this starter. Okay. So this is how this kit works, and if you have any doubt or problem, you can ask me. No, we don't want to change the starter again and again. Okay. Next time, if you will again switch on the lamp, then this metallic strip is earlier, but now so then what is your question exactly? So maybe there will be the problem with the this gas, or maybe the problem with the capacitor inside this. There are three parts now only. The gas, capacitor, contacts, nothing else. Understood? This capacitor also have some lifespan. Okay, after some time you need to change, right? Okay, so this is the theory part. You can read it. Whatever we discuss, it is written here. Okay. Now next home appliance is ceiling fan, right? So in the ceiling, this is also ceiling fan. Now what are the parts of the ceiling fan, right? So these are the blades. Okay, and this in the center you will find the motor here, through which the blades are connected. Okay, so if motor will rotate, blades will also rotate and will circulate the air, right? So what kind of motor used in this ceiling fan? Is it AC motor or DC motor? AC motor or DC motor? Yes, it is an AC motor. Which kind of AC? Single phase induction motor, right? Single phase induction motor. Okay. Now this motor also works on single phase 230-volt AC supply that we already have in our home. Okay, and there are some important parts needs to be discussed. So one characteristic means one thing about this motor is that it is not self-starting motor. Okay, whenever you are switching on the supply, motor will not rotate, right? Because it cannot develop the enough starting torque, right? So to provide the enough starting torque, we need to install one capacitor with this motor, right? So that capacitor helps to build the starting torque to run the motor. Okay, so capacitor is required to run this motor. So you can see in this diagram, this is capacitor. It is inserted with the series and with the starting winding, right? So this motor is also known as the capacitor and capacitor start motor. Okay, and what are the parts? So inside any motor there are mainly two parts, two main parts are there. So one is the stationary part, that is called stator. And another one is rotatory part, which is called rotor, right? So stator and rotor, right? Sometimes it is also called armature. Okay. So now two parts are there. One will be rotating, one is not rotating. It's stationary fixed part. Then there are two types of windings. Okay, windings means the okay. So the windings housed in the stator slot, which is known as the stationary winding, or in the case of ceiling fan, you can say the starting winding, right? And this is called the winding on the rotor is known as the rotor winding. Okay. Okay, winding represented by an inductor only, coil, right? So these are two main parts. One is responsible to develop the magnetic field. Okay. So let me show you the diagram in which you can see the various other parts also. There are a lot of many parts are there, but these are the two main parts of any motor. Okay, you can see students, this is called the frame or yoke made of cast iron on which the motor is supported. Okay, so this is the frame or yoke, right? Now this is the external view of motor. This is the internal view. Okay, now you can see this. This is a motor shaft, right? So when the rotor, this is rotor, this is rotor. So when the rotor rotates, rotor rotates on the axis of this shaft, right? And this part is known as the stator. Fine. Part is known as the stator. Understood? This part is rotor. So stator is stationary, it is not moving anywhere, and the rotor is housed inside this stator, this shaft. Through this shaft, this rotor is connected to the stator. Okay, and this rotor will rotate. Okay, and with this rotor, this shaft will rotate and the rotor will rotate. And this is the bearing to reduce the friction which is occurring during rotation this rotor. So it reduce the noises, it reduce the noise and also the friction. Okay. Then this is the cooling fan and bell, right? Other parts are also there, and bracket bearing housing. So inside this stator you can see this is the winding which is housed inside the stator. This is called stator winding, right? And inside this rotor, you cannot see in this figure, but inside this rotor there are slots, and in that slots also the windings are housed. So that is called the rotor winding. Understood, students?
Yes, ma'am.
And if we are talking about the external view, this is the capacitor here installed with this motor, and here are the connecting terminals of the motor. This is the shaft, right? So here you can see where is the motor in this fan. Can you tell me?
Ma'am, the circular
Yes, so this one is this circular part is the motor, right? So when you are starting the fan, this circular part will rotate, right? So this is the rotor of the motor, okay? And there's a cap you can see here. It's under this cap there will be the connecting terminals of this fan to the switch. Okay. Now if you see the circuit diagram here, so you can see this is the supply from the switchboard. We have 220 volt single phase, and here is the switch. Through switch the motor is connected. Okay, so capacitor is connected with the series of starting winding, and this is the running winding, rotor winding. This is the rotor we are representing here. Okay, so one winding on the rotor and one on the stator starting winding. Okay, so and this is the capacitor which provides the energy to develop enough torque in the starting to run the motor. If we are not connecting the capacitor, you will not be able to start the motor by only switching on the supply, right? If you are not connecting any capacitor, right? अगर आप कैपेसिटर कनेक्ट नहीं करते हैं तो स्विच ऑन करने के बाद भी मोटर स्टार्ट नहीं होगी, राइट? फिर उसको स्टार्टिंग टॉर्क नहीं मिलेगा इतना. So sometimes the capacitor is suppose aged, so the capacity to store the energy is means decreased by means of the capacitor. In that case also, it may happen that your motor will not run, or the motor speed will be low, right? So even if you are regulating with the fan regulator, the motor speed will not increase. This is in most of the times this is due to this capacitor aging, right? Understood, students?
yes, sir.
In that case, we need to replace the capacitor to run our ceiling fan. These are the components of ceiling fan: yoke, motor cover, blades, capacitor, bracket, bearing. So blades are not the part of the motor. It is connected with this motor. These are the blades. Okay, all other are the parts of the motor. The yoke, motor cover, the bracket, capacitor is also not a part. Means we need to install it individually, separately. Then bracket, bearing, down rod, switch housing. Okay, so this is down rod. Okay, connect the ceiling fan to the ceiling, right? Okay, so now if we are talking about the blades, we talked about the motor of this fan. Now we will talk about the blades, right? So blades of this ceiling fan, you can see here are suppose 4 blades, right? So these are precisely weighed and matched. And if you want to change any blade, you cannot change any one blade, right? You need to change the blades in the sets. Okay, so these blades are fixed with a particular pitch angle, right? So the pitch angle of the high quality fans are between 12 to 20 degree, and less expensive fans have a lower pitch, right? So high degree of pitch allows for more air movement, and lower pitch angle will allow any means less air movement, right? So if the pitch is more than 12 degrees, so noise will also increase with the movement of the fan. So and too little blade pitch can result in too much RPM that can create noise, right? So the blade RPM, pitch, blade span, and motor size are balanced for best performance, right? Any doubt in this, students?
No, ma'am.
Yes. Sorry. See, this is what I am saying. Once the capacitor is charged, right? That depends on the capacity of charge, capacity of the capacitor, right? How much charge it can store, right? Understood, students? So what you want to remove the capacitor and you want to increase the voltage. No, you cannot do this. You need to install the capacitor only. Okay, because we cannot increase the voltage. In our node, you got single phase AC supply, right? How you will increase this voltage? First question is this. How you will increase? Yes, tell me how you will increase the voltage. Hmm? I'm not getting your voice. Can you please speak loudly? We can use. Okay, so there is the rating also of the motor. Okay, so the rating is at a particular voltage and current this motor can run, right? You cannot provide the voltage or current, I mean voltage more than the rated voltage, right? Understood? Understood, student? Every appliance have some rating. Okay. Okay, then now next topic is the fan regulator. Okay, now we can control the speed of our fan using the fan regulator. So what is inside the conventional fan regulator? If we are talking about the conventional fan regulator, so what is the basic principle? What is the construction inside it? What concept we are using to vary the speed of the fan, right? So inside this fan regulator, you can see here there are resistors. Okay, you can see the diagram here, circuit diagram. This is the supply. Okay, and through this supply, the capacitors are connected in series, and in series the motor is connected with this. The winding starting in the starting winding, it is connected in series, right? So when you are cutting, means when you are rotating this knob of the regulator, suppose on speed 1, speed 2, speed 3, speed 4, speed 5. So that means if you are going 1 to 5, you are increasing the speed, right? And if you are going from 5 to this 1, so you are decreasing the speed. Okay, so and at 0 it will be off, right? So what will happen means we are here controlling the current, right? Whatever the current going to the motor, we are controlling here. So we are controlling the current by using these registers. Okay, so when your knob is on, suppose 0, okay, so circuit is not closed, it is open circuit, so the fan will not start. Okay, it is, I mean, fan will not get any current supply. It's, since it's an open circuit, right? Now I suppose if your knob is on 1, this arrow will be on 1. So how many resistors are connected in the circuit? How many resistors are connected in the circuit? Can you tell me? 4 resistors, right? Suppose the resistance value is R, 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 R. All 4 are identical. Okay, so 4R, total 4R resistance will be connected, right? So what is the current flowing in that case? I equals to V by 4R, V upon 4R, right? Yes or no? Now if your knob is at 2 number, right? This is 2. So now you're increasing the speed. Is the current is increasing. You cut out, means one register is not now cut out. Okay, so only 3 registers are in the circuit now. So 3R register, the 3R resistance value you will get. So what will be the current? I equals to V by 3R. So V by 3R and V by 4R, which current will be more? Can you tell me this?
V by 3.
So current now increase, so speed is also increase, right?
Ma'am.
Now if your knob is at number 3, so how many resistors you will have in the circuit, connected resistors?
2.
2. So means 2R resistance value is connected in this circuit. So the current will be more again as compared to V by 3R, V by 2R will be more.
Yes, ma'am.
So the again the speed will increase, and likewise you can increase the speed till 5. So if your position at 5, this regulator knob position is at 5. So how many resistors are connected? Suppose this arrow is on 5 here. How many resistances are connected in the circuit?
0 register.
Okay, means external, no external resistor of regulator, means regulator resistors are not connected. Okay, only the current is flowing through this directly.
Yes, ma'am.
Okay. So this is how this conventional regulator works. So this is the picture of the conventional regulator. Means in earlier we used this type of fan regulator. Nowadays modern regulators are comes into the picture, and so these are the modern regulators. So what is the problem with these conventional regulators? The problem is the power loss. Significant power loss are there. Okay, because registers are there, we are cutting the registers, so I square R losses will be more. Okay, so that is overcome by this new electronic regulators. Okay, so these regulators controls means the current, but in different way. Means it they use the electronic circuit using triac diac and controls the current, right? So there is no power loss, means as compared to the conventional, there is much less power loss. The I square R loss is less, and the size is also reduced, right? And it gives the continuous speed control. This type of regulators, right? Now new technologies are also coming nowadays. The Wi-Fi, you can control your devices through Wi-Fi, home appliances through Wi-Fi. Okay, so these are the new technologies, the Internet of Things, right? Now coming to the next appliance, electric iron. Okay. So what is the electric iron? Means what are the different parts of electric iron? What are the different parts, students? Okay, so the parts are, students, the sole plate, the plastic handle, the iron cover, the heating element, the thermostat, right? So thermostat is like the metallic strips, okay? Heating element is responsible to produce the heat at the sole plate, okay? Sole plate is made of the material, we use some material like mica, okay, which is good conductor of heat but insulator for the electricity, because we don't want to pass the current, we only want to pass the heat, right? And this is the iron cover, this is the plastic handle, you know that, and if this is the knob to control the volt, they control the temperature of the sole plate, right? So what is exactly going on here? So the heating element is a nichrome coil, right? And it has a very high value of resistance. So when electric current is passed through it, okay, so it produces the heat, right? So and it transfer on the sole plate. Then it transfer to the sole plate. So the insulation of mica, which are good conductor of heat but insulators to electricity, are used in this plate. In this way, simple iron can work. Now, if we are talking about the temperature control, so as you notice in your home, if you see the electric iron carefully, this is the knob to control the temperature. At this knob, there are some fabric names are written like cotton, silk, wool, right? So, if suppose if we want maximum temperature, that you need to select it on cotton, suppose, right? So when you are moving it to cotton, so the thermostats are there inside this knob. So these strips will get tighter, and the if we rotate the knob to increase the temperature, it will get tighter, and it will get tight. And if we rotate for the less temperature, it will be loose, and it allows the current to pass to this heating element, right? So when it is more means it is tightly connected, so current can pass. Okay, there will be no loss of current. If it is loosely connected, then the heating element will have less current and will produce less heat, right? So in this way we can control the temperature here from here. So various parts we already discussed. Okay, you can read this manual once time for at least. Now, if we have some fault in this, means suppose some insulation breakdown will happen in the iron. So means even we are using already the mica and obstes in this electric iron. This manufacturer providing this material to avoid any shock, but uh, sometimes it may happen that insulation breakdown will be there inside this iron, so the leakage current will pass. So it touches the surface, and if we are touching the electric iron, we can get a shock, right? So to test this, we can use this to test the leakage current. We can use the tester or the test lamp, right? So if you want to test the using the test lamp, you need to connect the test lamp to the surface and the neutral terminal of the socket, another terminal to the metallic part of the iron. So if that lamp will glow, then it shows if the current is there, leakage current is there, fault is there, right? If lamp is not glowing, means no leakage current is there, iron is okay, right? Then if earthing wire is not provided and if there is a short circuit between the heating element and metallic part, then also the lamp will glow, right? This is also a kind of fault, uh, insulation breakdown or short circuit, right? Then comes the crawler. Okay, so this is to test the armature winding of the motors. So in our home we use various appliances that have the motors, single phase induction motors. Like we are using mixer grinder, right? We are using the water pump, we are using the fans. So all the appliances have all appliances have the motors inside it. Okay, so motors means single phase induction motor mostly. So if some problem will occur in the winding of the motor, right? Suppose armature or rotor core, right? Armature winding, rotor winding, or rotor core, some problem is there. So to check that winding, we use that crawler, right? Here is the ammeter and supply terminals. So what we will do, we will take out the winding, the armature winding will put here on the crawler slots. Then if we turn on the supply, so this crawler will work like a means it will work like a magnetic cell. The magnetic field will be produced in the slots of the crawler, right? So if we want to check our armature winding is working fine or not, so if it is working fine, so magnetic field will be there. So if you will put any iron strip there, so in proximity with this crawler, so there will be a magnetic force experienced by you. So it means that the armature working is well, armature winding is fine, right? So the crawler act as a magnet. Now carry the iron strip parallel each slot of the armature. If the coil in that particular slot is healthy, there is no effect on the iron strip. And so, but if the coil is burned in a particular slot, the iron strip will be attracted towards that slot. So the windings are always put in the slots, right? So we need to check which slot is working fine, which is not. So we will put iron strip in each slot, okay, and we'll check accordingly. Now this is induction cooker, okay. So how this induction cooked up work? So you see this diagram and tell me what you think about this. See this diagram. How it means by which equipment it is resembling. Can you tell me, students? Huh? Yes, transformer, right. So what do you think? How it is, according to this diagram, this is induction cooktop diagram. So how it will work? Since the name is induction cooktop, so it's work on the principle of electromagnetic induction. How it will work? So we'll take a 5 minutes break, students. Think about this, right? Then we will discuss. Okay, students. How this in this diagram, how you will explain the working? Can you tell me? Yes. Anybody can explain? Sorry. Okay, so there are two coils you can see in the inductors, right? So as we already see in this diagram for the transformer, right? So this is the supply side. From here we will energize our coil, right? And this is the another circuit, another coil, right? And through this coil we will connect our load, right? And load is what here? Your utensils in which you want to cook the food, right? So now what will happen here are the N ratio 1 turns ratio of this coils are there, N ratio 1, right? So V in means voltage supply we are giving. So what voltage supply we will give? We will give 230 volt AC, single phase in our home. We will connect the switch, we will connect the plug to our switchboard, right? And we will give 230 volt, 50 hertz single phase supply to this induction cooktop, right? So this coil is at the side of the supply and this is at the side of the load, right? Load is what? Your utensil. So when you are connecting the supply, the current will start flowing in this and AC current is flowing in this and this coil, this first coil, input side coil will develop an EMF which is nothing but equal to E equals to minus N d phi by dt. Yes or no? Yes. Now this second coil which is at the output side, the second coil is there. So this coil is in close proximity with this first coil. So mutual induction will be there. Due to that mutual induction, this second coil will also have some EMF across it. Yes or no? So current will flowing through this load. We are denoting this load as a resistive, but actually our load is this, right? So this pan is of high magnetic permeability material. It is made of ferromagnetic material. Okay, and it is of having high magnetic permeability, which allows the flux, right? So what will happen here? Here is a circular plate. This plate is also there. Besides this load, means we will put this load on the circular plate. So it will generate the eddy currents. Right, eddy current is what? Eddy current is what? What is the eddy current? So these are the circular currents which doesn't produce any useful electric power but produce heat. It's a kind of loss, right? So due to that Joule effect, the heat will be produced, okay, and the utensil, whatever you are cooking in the utensil, that will be cooked. So there will be the hysteresis loss also, because you are putting this ferromagnetic material pan on this plate, so there will be the hysteresis loss also. Okay. Now what we do is means we require to generate the eddy currents, and we require to give high frequency to this coil, high frequency supply. So we'll use one IGBT, will switch our frequency. Okay, IGBT will be installed here, insulated gated bipolar transistor, right? So when we are giving the supply, so supply is having 50 hertz frequency, but it will be increased by the IGBT and will give high frequency in as a high frequency supply we are giving to this coil. So what will happen to because of this high frequency, what will happen? We require low inductance coil here, right? Because inductance is XL is equals to 2 pi FL, and if you are finding L, that will be equal to XL upon 2 pi F. Okay, so we can see that inductance is inversely proportional to frequency. So if you are increasing the frequency, inductance value of the coil will decrease. So that if we use low inductance value coil, so cost will also be affected. So and cost will be reduced at high frequency low inductance coil, right? If we are using low inductance coil, cost will reduce. Okay, so we can resemble this circuit with the electric transformer. Primary is the copper coil placed inside the induction cooker, and the secondary is the bottom layer of the pot. Okay, so two coils are there in the transformer, primary and secondary. So this is the primary of this induction cooker. This you can say secondary, which we are putting beneath this load, this pan, right? Understood, students?
Ma'am.
Yes, ma'am.
Okay. So a student asked one question regarding this induction motor in the chat box. I think it's about triac regulator, right? Okay. So first, first you need to understand the working of diac and triac to understand this circuit in detail, right? So if you want to, means triac is a three-terminal device, diac is a two-terminal device, and it can flow the current in both direction, right? Triac. This is symbol of triac. Okay, and first you need to see the working. Okay, so I will share one video with you. You please go through that video if you want to learn in detail this diac and triacs, so that you can understand, right? Next is if you are talking about the start capacitor run motor, that is single phase induction motor. So what is their students? So means single phase induction motor is not self starting. Even if you are increasing the voltage, it means you cannot increase the voltage beyond the rating of the motor, right? So if it is motor rating is 230 volt, so you cannot give more than 230 volt, right? It means you need to follow the rating, right? Because otherwise some insulation breakdown will be there, or some kind of other problems will be there. But what is your question that can we replace the capacitor in this? We cannot replace it, because if you use higher rating motor also, that will not also start. Okay, if you are giving high voltage and using higher voltage motor, that will also not start, because single phase motor is like this, because we are giving the single phase supply to this, and the flux generation will be single phase and it's alternating in nature, so it's cancel its effects. So there is net torque is zero in starting, right? So that's why if you want to run it without capacitor, So you need to use the two-phase or three-phase motor, right? Two-phase motor. If you are converting this motor to two-phase, then it's okay. It can develop the starting torque, and you can it without any capacitor. But single-phase motor, induction motor cannot start. Understood? It is written here. You can read. Whenever you are coming to this lab, you should read the lab manual first. Okay. So two-phase motor is there. If you are place the windings, means two-phase motor winding will be placed like 90-degree apart. So the net torque will be you will get some net torque which is required to run the motor, right? But not in single phase. Distributed windings are there, so net flux will not be will be zero, right? Understood, students?
Yes, ma'am.
Nowadays this brushless DC motors uh, uh, companies using in construction of fans. Okay, so these are also used, but mostly motors are single phase induction motor. So any other question?
Ma'am, the video.
Really? Yes, please speak loudly, students.
Ma'am, the video which you are going to send.
Video for that direct working I will send you. Yeah, I will share the link, but that is not the part of this experiment. This experiment is about home appliance, not for the electronic circuit components, direct and direct. Okay, but if you want to learn, I can share. I will share here in chat box. Wait a minute.
Okay, ma'am.
Student, any other doubt in this experiment?
No, ma'am.
I've shared the video with you in chat box. You can click on the link. Okay, you watch this video after this session. Okay, when you got free time, you can watch this. Right? Roll number 74. When you get free time, you can watch this. Right now, we are discussing the next experiment. So this 7th experiment is completed, student, and now we are moving to 8th experiment. 8th experiment is control of electric panels, right? So on the next session, there will be the assessment for experiment number 6 and 7. You need to prepare for 6 and 7 if you want to prepare anything. Okay.
Yes, ma'am. Just a minute, students. I will show you one more thing. The students, you can see this is the ballast. This is called the ballast, which is nothing but the choke coil. Okay, in the tube light, and this is the starter. Okay, so this is installed with this tube light lamp, right? Whole things are known as tube light kit, right? There are some holders. These are the holders in which lamp is connected. They are holding the lamp. Okay, and in earlier days, you can fill this lamp. Okay, earlier days the ballast was here, and the starter was here. Okay, you can see on the kit, but nowadays it is hole covered. The kit is hole covered, you cannot see outside this ballast or this starter, right? It is inside only, but actually it looks like this. This is choke coil, this is starter. Understood, students?
Yes, ma'am.
Sometimes the starter is looking like a transparent one. It comes with the transparent body also. Okay, so you can recognize how what part is it is. So now we have the experiment number 8. Okay, so this is experiment number 8. So the aim of this experiment is demonstration of various components in electrical control power panel, right? So first of all, you should learn what is electrical control or what is the power panel. Okay? Electrical panel. So what is electrical panel? What do you think? This control panel, electrical control panel, or what is electrical panel, or what is the electrical power panel?
Ma'am, a box which contain main power line.
Can you repeat your answer?
Ma'am, a box which connects a main power line
Which connects the main power line to what?
to our home. मतलब वो घर के बाहर होता है ना ऐसा मैम एक.
So what you are expecting? What will be inside this box? So the panel which consists of all the equipments which used to control the electrical system is known as the power panel, or you can say the control panel or electrical control power panel, right? Right? Okay, so what are these control equipments or components used for the electrical system controlling, right? So first of all, we have enclosure. what makes a proper control panel. So we have an enclosure. Okay, it's a box type box. It's a box. Okay, so the control to make a control panel or electric panel, these components may be required, right? First of all, enclosure, then analog voltmeter to measure the voltage continuously, then analog ammeter to measure the current continuously, and select switch to select the phase. If suppose in the industries we have these control panels, big control panels, right? So there are three-phase supplies coming, right? We can so we can using the selectors, we can select the phase, right? And there are LED type indicating lamps which shows the if some danger is there, so red light will be indicating. Okay, if everything is working fine and supply is on, so green light will be indicating. So these are LED indicating lamp installed on the power panels. Then push button switch are there to stop or on the process or supply, right? Then SFU, okay, and then fuse unit. SFU means this fuse unit, and power contactors are there, overload relay is there, timers are there, control wires, control fuse with base, annunciator, HMI, human machine interface, MMI, fuel loop, scrimping tool, right? So all these things we will discuss, and I will show you the picture of control panel used in the industries. Okay. Okay, so you can see, student. So these are the control panels here. These boxes you can see, these are the control panels. On the control panel you can see the indicators are there, push buttons are there, the voltmeter ammeters are there. They are measuring and they are indicating everything. Okay, so and the box in which all the components are fixed, so this box is known as enclosure, right? So let me show you the internal view of this panel. This is the exterior of the panel. So you can see from inside it looks like this. So a lot of things are installed here, a lot of components that we are discussing in the panel, right? So this is the internal view, and all the controls are available inside this. You can see this is the control panel, right? So these are the voltmeter, ammeters, push button indicating lamps. Okay, and if you will see closely, so these are the selector switches. These are the selector switches. We can select the phase, and these are the push button. Okay, this is the emergency on off button, right? This is the LCD display. So this panel measures all the parameters, and if some fault is there, some problem is there, so the fuses and all will work, and it will display this there is a danger, or the system is working fine. Okay, so these are the push buttons of different colors, so you can start or off the process using this push button. The selector switch is to use select the phase, right? Understood, students? So all the components that is fixed inside the control panel, we will study in the next session. Okay, so prepare for the assessment for 6th and 7th experiment. 8th we will complete in next session. So any doubt you can ask me, otherwise you can ask the meeting. Yes, anything? Any problem?